Albert Einstein. I think we've all heard about this name. He's an iconic figure. He's the iconic figure of science and technology and physics in particular. Not only of the 20th century, but probably ever. And at least he's one of those physicists who has made amazing breakthroughs, not only in the theories, but in the way we see the world. And that's really what you want to come up with in scientific research, especially in physics. You want to have a new vision of the world that somehow makes much more sense than all previous visions of the world, and that's exactly what Einstein did repeatedly. But it wasn't always that easy for Albert Einstein. The thing is that when he was studying at the University of Zurich, he was a bright student. He was basically always having the best scores in math and physics, but he was not caring much about the other topics, and as well he was not very he seemed to have been a bit annoying with the professors, and so it was actually hard for him to find a PhD position, something like that, to go on with his academic career, and so he actually had to leave academia, and so he searched for small jobs here and there. He became a teacher here, a teacher there. In the end, he got a job at a patent office. He was a clerk. It wasn't a great job. Not that I have anything against the job of patent offices, but Einstein didn't feel like he was doing what he was supposed to do. And of course, what he was supposed to do, at least according to him, was physics. He wanted to do physics research. He wanted to figure out new things about physics. Now, he couldn't get hands-on with experiments and stuff like that, so he instead did a lot of thought experiments, in his head. And this is what he's really famous for. And so this started in the year 1901. Then at some point he became father as well. And then came the year 1905. His ideas had matured, and there they came. It was 1905, the miracle year of Albert Einstein, the miracle year of all of physics, because hardly ever in one single year had physics seen so much progress. And what's amazing is that all of this progress, all of these breakthroughs that were going to come in 1905 came from one single person, the great Albert Einstein. In this single year, he published 4 groundbreaking papers. Really, each of these 4 papers could have won a Nobel Prize. The first one was about the existence of atoms. Basically, he gave the conclusive evidence for the existence of atoms through the study of Brownian motion. The second was about the existence of atoms of light, which we now call photons, which explained the photoelectric effect, or rather the fact that the photoelectric effect only works for high frequency light, like ultraviolet and stuff like that, and not huge amount of low frequency light. Anyways, I'm not going to go into details here. The third paper was the one of special relativity, probably the most astounding among them all, I think, because it just started with one single postulate, simple postulate, namely that the speed of light, or rather the speed of causality, is finite. And then he derived all the new stuff about space-time, about flat space-time. We've already discussed it in a previous video. And then the rest of these papers, E equals mc squared, an amazing insight into the nature of mass. The mass of a system, of a physical system, is its energy divided by c squared, if it is at rest. And that's groundbreaking. That was the key to understand the structure of the of the nucleus, at least the energy that was underlying the nucleus, and why it is that when you break it, you have so much energy, or when you have a fusion of two small nucleus, you have so much energy that comes out of it. Yet, however brilliant these papers were, they got largely unnoticed, and Einstein had to keep working at the patent office until 1908, so 3 years on. Unfortunately, at that point, he started to gain recognition, especially from Max Planck. And since Max Planck was the big man of physics back then, this had a lot of importance, and eventually he got a position at the University of Bern. And then quite quickly after, he got offered a position at the Berlin Academy, the summum of the world of physics. And he went there. At this point, he started to set himself bigger and bigger challenges, and especially he worked on the theory of general relativity, working out the idea that he had in 1907, as we already discussed in this video. And then in 1912, he realized that maybe the curvature of space-time was the answer to the problems he had. So he went to Zurich, as we discussed in this video, and then developed the theory of general relativity at last, and explained this curvature of space-time as we did in this video. And in 1915, there's a great story between Einstein and Hilbert. Basically, at that point, Einstein was starting to be the big figure of physics. Maybe not quite yet, but he was definitely the young, rising figure of physics back then. And there he was at some point talking at Göttingen to David Hilbert. David Hilbert is the greatest figure of mathematics, the greatest, at least one of the greatest mathematicians of that time. And so Einstein at some point gave a talk, and Hilbert was in the room, and I think there's a letter that Einstein wrote to a friend of his where he's saying that nobody was understanding except for this one guy, except for David Hilbert. In November 1915, they both proposed their equations of general relativity, which were written differently but not to be equivalent. And Hilbert actually got his first draft first, but like 3 days before Einstein. Then Einstein had this great equation, and then Hilbert had to make a few corrections to his version. In the end, there has been a bit of debate between the two about who first came up with general relativity, but in the end, Hilbert acknowledged himself that the theory was Einstein's. And I think at this point, both were convinced that general relativity was the right theory, that there was no other possible theory. And it's, as I said in this video, it's only in 1919 that the theory was confirmed by observation of solar eclipses. And at this point, in 1919, when Einstein got confirmed by experiment, he became a superstar overnight. It was Einstein beats Newton, and Newton was the big guy back then, he still is. And to beat Newton, it really means that it's like once in 300 years, so 300 years of, maybe 250 back then, of human knowledge was superseded at last, and the man who destroyed, well, not destroyed, but improved upon or revolutionized it all is Albert Einstein. He became a worldwide superstar, even though the experimental evidence were not that conclusive. In fact, they came just after some negative results by Campbell. Anyways, I won't go into the details, but it's a very tricky story. The thing is that Einstein was nevertheless a superstar before his theory was really, really nicely backed up by experimental evidence. Also back then, it was the end of the war. During all the war, Einstein was against the war. He wanted the war to stop. He was a pacifist. And the thing is that the man, Sir Eddington, who would confirm Einstein's theory through observations of eclipse, was as well a pacifist. And Eddington had seen that having this scientific collaboration between two countries that were at war or that are at war would be a super wonderful sign that international collaborations could allow for something much more grandiose, something much more wonderful, so much more. And Eddington saw that the key to get there, to have this key message for all of the population, was to prove, to vindicate Einstein's theory. And the thing is that because everyone knew that Eddington had this goal in mind, when they saw that Eddington was the one who was confirming Einstein, and they saw that his observations were not that clear-cut, they questioned a lot of the results. And that's really fair. I mean, I would have questioned it as well. I think there was an additional reason to have this kind of doubts, which was namely that there was another observation just before Eddington's that disproved Einstein, or at least that suggested that Einstein might be wrong. And I think it's only in 1921 that Campbell, so the one who had said that Einstein might be wrong, would do other experiments and would actually vindicate very nicely, very conclusively Einstein's theory of general relativity. And at last Einstein got the Nobel Prize after that. But the irony is that he was chasing this Nobel Prize because he promised the money to his ex-wife, because he got divorced at some point, and he wanted this money for his ex-wife to get the custody of his kids. Anyways, the thing is that he was really chasing this Nobel Prize for this reason, and he really thought that being vindicated, having his theory of general relativity vindicated, would get him the Nobel Prize for sure. And definitely, like, this was both like 3 Nobel Prizes. But he actually got the Nobel Prizes just after that, but for an old work that he did in 1905, namely the one on the photoelectric effect and the existence of photons. So at this point, Einstein was a superstar. He started to get involved into quantum mechanics, which he started. There was this amazing Bohr versus Einstein debate. Now today they are often told as the victory of Bohr, and it is true that Bohr won a lot of battles, but back then it wasn't that clear-cut, like especially there's the EPR paradox, which I'll get to talk, but not now, that basically convinced a lot of people that Einstein was right in this Bohr versus Einstein debate. Not that it really matters though, it was more like philosophical question about the true nature of reality, not about how to use the equations to make predictions or to engineer our world. This was like they all agree, Einstein and Bohr agreed about all the predictions and engineering possibilities, at least the engineering possibilities as far as they could see. But on this one debate here, it seemed like Einstein had won, basically. He had won, but not conclusively, of course, because there doesn't seem to be any experiment that could declare a winner to this debate. That was back then, because since then there was the Bell's theorem and then the experiments by Alan Asper, which declared Bohr winner of these debates. But it was very tight, and it was a fascinating debate. Very roughly, the debate was about whether quantum mechanics was complete and whether the world was really random as quantum mechanics predicts it. At least quantum mechanics as interpreted according to the so-called Copenhagen interpretation, which is Bohr's interpretation. So really, it's more like Bohr's quantum mechanics. And so Einstein said that Bohr's quantum mechanics was at least incomplete, and that the probabilities that emerged out of this theory were not probability about the randomness of nature, but probabilities because we don't know exactly what the world is made of or how it is. As the story goes, Einstein just kept repeating, God does not pay dice, and at some point, Bohr, a bit annoyed by Einstein, replied, Einstein, stop telling God what to do. And then in the early 1930s, in Germany, there was the Nazi regime that started to gain power, and Einstein was Jewish, and more generally, all the academics, all the intellectuals were fleeing this kind of regime, which was really unsafe for them. And a lot of them went to the US, and Einstein did as well. And so he immigrated to the US. And in the US, he became a professor at the Institute of Advanced Study in Princeton, which is now, which was back then and is still today like the world center for mathematics and theoretical physics. And the statue of Einstein is a bit everywhere there. I took one picture with it, went there last summer. And then he became an American citizen, which was his sixth change in citizenship. He grew up as a citizen of the Kingdom of Württemberg, then became stateless, then became Swiss when he was working at the patent office, then Austrian to get a position over there at some point, and then German. Yeah, eventually he did become German, and then American. So he became American in 1940. At that point he was a clear superstar. And when the Second World War was triggered, Einstein was very worried about the fact that the Nazi regime might have nuclear weapons. He knew that there had been a lot of advancements in nuclear physics in Germany. So he co-signed a letter to President Roosevelt back then to suggest to assemble a team to create the first nuclear weapon. And so he really was at the starting of the Manhattan Project, something that he would later actually regret. But I think back then, as an immigrant from the Nazi regime who has undergone the Nazi regime, along with many others like von Neumann, if you really feel that it's hard not to want to have this nuclear weapon to defend yourself. Anyways, he regretted it for the rest of his life. In the end of his life, he was actively searching for a unification of the theory of gravity and the theory of electromagnetism, because the theory of the nuclear force was not that clear back then. Anyways, and he wanted to have a theory of everything that's part of the way, the philosophy that Einstein has in mind, that the universe was something sensible, that we could write the equations of the entire universe, that the universe had to make sense and stuff like that. All these reasons why he had to have these debates with Bohr, and that he had to oppose Bohr. But unfortunately, he passed away while trying. Anyways, today his legacy is huge. For me, the greatest legacy of Albert Einstein was the fact that he gave an amazing stimulus to a whole new generation. He was an amazing inspiration. In the 1920s, when general relativity had been confirmed, when general relativity had shown that all of physics, at least of the physics of gravity, had to be rewritten. And like everyone wanted to know what it was all about. All the young scholars, and thus there was just after a huge generation of young scholars. They all learned about the space-time curvature. But the thing about the space-time curvature is that there's not that much to say about the space-time curvature. It's not. The theory is complicated, but once it's there, then it's there. There's not that much more calculations that can be done. On the other hand, back then the structure of the atoms were becoming more and more of an enigma. And thus this new generation started to work on atoms, and they developed the theory of quantum mechanics. So while it is true that Albert Einstein was the father of quantum mechanics because of his 1905 papers, and while it is true that he helped develop quantum mechanics as well, coming up with, for instance, the EPR paradox, I think his contribution to quantum mechanics is even greater than that, because he is at the origin of this new generation of people, of this whole amazing crew of people, of the Dirac and Schrödinger and Heisenberg and Pauli and Fermi and so on, who would really all together within just a few years completely revolutionized a whole understanding of basic physics, of elementary things. And as we know now today, it's a physics that is so counterintuitive, so years away, like from anything that anyone who could have possibly thought of before that time. And really, the man to thank for that is Albert Einstein. And I think even today, there are still generations of new physicists or even mathematicians like myself who are inspired by Einstein. And we love what we do. I love physics hugely because of people like Albert Einstein who showed us how counterintuitive, how cool these stuff could be. It wasn't just about describing what the world is, it was really about guessing and proving stuff, and not relying on your senses, but relying on the mathematics and of the data, of the observations, of the careful observations, that the setup that we consider, the rigor that we put in all of that. And that's really the legacy of Albert Einstein. It's not only special relativity, general relativity, quantum mechanics, and the theory of atoms. It's also, I think most importantly, a whole culture of science that Einstein has inspired. And for that, Einstein is unique. It is the iconic figure of science.